Yes, we can start now. Uh, we'll, what we have discussed in the last lecture, we will continue from there. If you have any queries, you can ask. So let me share the screen. Okay. So yes, I hope my screen is also visible to everyone. And I welcome you all to this first session on second day of this GM course. Let us quickly recap. Can anyone quickly confirm that audio and video is perfectly fine? Yeah. So let us quickly recap what we did. Yesterday we understood uh, what is risk-free asset and risky assets. Then we understood bond and stock. Then we understood the problem that yes, can we minimize our risk? Of course, we cannot make it zero, but can we minimize our risk? And we saw that yes, by using options, the bread company has minimized its risk. Okay. And then we saw derivatives, forward, future, option, swap. I'll show you one beautiful picture today that what how many types of derivatives are there. And then we started from contract, simple barter system, then one contract, and then that kind of contract is called forward contract. And if we tweak that contract a bit, it is options. So what is that? The name is itself clear that one party will not be obliged there. One party will have the option, right? One party will have the option. So that's why this contract is named as option contracts. Okay, and then we realized that yes, it is very important to have the fair value of this option contract, right? Otherwise, there will be problem in the economy. Okay, so now I request everyone that if you have any queries, you can ask. Otherwise, we can move. So then we discussed about no arbitrage principle, not mathematically because mathematically you have been taught by Professor Obeck. He is teaching the whole core mathematics involved in these concepts. So I request everyone just try to understand. He's teaching in a very simpler way. Just try to get that concepts mathematically. He's using linear algebra concepts. And then we discussed that, okay, there was one seminal model. Of course, many happened from 1900 to 1973. But yes, we will directly jump to 1973 because we have to cover so many things. So in 1973, the model came as Black-Scholes model. And uh, what the beautiful thing about that model that they provided a partial differential equation, basically, right? And that partial differential equation, if you solve, you'll get the option price, right? So I'll tell that partial differential equation, but before that, I think I should discuss a few more terms, right? Then only we will go for Black-Scholes PD. So please be clear that what is our objective today. I have two sessions today. So what is our, this is lecture 2. So what is our objective? We will try to understand some more concepts about option pricing. Those are basic in nature. And then we will try to understand how numerical methods are involved in this. Okay. So now, before starting, so Professor Obeck was using some terms like call option and put option, call option and put option. So let us not try to understand in this way. Let us try to understand in the example which we have discussed. What is the example we have discussed? Wheat and bread, right? The example we have discussed, wheat and bread. And what we realized at that time, that A is a person who is having wheat and B is a person who is the owner of bread company. Now, what I told you, that here bread company will pay some premium, right? Will pay some premium because they want to have this extra advantage, right? They want to have this extra advantage to buy or not to buy the wheat. But he is obliged. Here, he is obliged. Obliged means it's mandatory. He cannot say that I will not sell. Right? That we have realized. But and this A will take that premium and they will fix some price, suppose 25 rupees per kg, whatever, right? That is not a big deal. So they fixed this. Now there are two concepts. One is call and put option and one is European and American option. So both the concepts we will try to understand from this example only. Everyone, okay? So first concept. So why do you did not ask to me that why B can have this kind of leverage, why A cannot have? So here what, B is paying premium and is having right to buy. Everyone agrees with me? B is having right to buy. That means I have right to buy. I mean, if I wish, I will buy. If I don't wish, I will not buy. Agree? Everyone agrees with me, right? So why don't you ask that why can't A has this kind of right? Why can't A has this kind of right? If B can have this kind of uh, right, so if B can have this kind of right, then A can also have this kind of right. So what will happen in that scenario? Similar. Let me change the color so that it will be clear. Now what happens? A is a large wheat. Suppose he is having so many farmhouses, and B is not that big bread company. Now A is saying that no, I will pay you the premium, right? I will pay you the premium, but I have right to sell. That means what? If I wish, I will sell. If I don't wish, I will not sell. But if I will sell, he has to buy, obliged to buy. Why? Because he has taken the premium and whatever the rate they have fixed. Is it clear to all the participants that it's not that only the buyer is always paying the premium and having the right to buy? No. So it is in the both the way. So who will pay the premium? That is important. If he is paying the premium, here he is seller, right? Please try to understand. He is seller. He is buyer. Same here. He is a buyer and he is a seller, right? So if A is having the right, that means A has the right to sell. If B is having right, that means B is having the right to buy. So can anyone from the participants tell that which is called call option and which is called put option? Anyone? See, these are small observations. So once it is clear to you, then you will be more attached to option pricing problem. And those who are interested in research in this dimension, they will also be able to understand. Those who are going to understand only for their jobs or for their career, that will also be. So one of them is called call option and one of them is called put option. So this is called call option, right? Right to buy. And this is called put option. First call, yeah, Sarthak, thank you. So fantastic, right? So we are crystal clear that what is a call option and why we need two types, because it is not always that we have right to buy. It is not always that we have right to sell. Agree? So we have call, we have put. I hope it is clear to each and everyone. So let us move forward. Now, next terminology professor has used, and you should know, right? So European and American options. American style, American style options. Right. So I don't know whether anyone of you is comfortable in that, but let me tell you in a way that again, that same example, A, B, because I'll change the example, then you might feel that, oh, now it is confusion. So the idea is simple that A is again the wheat seller and B is again the bread company. Okay, so now the query is that same. So now again, suppose they have fixed, whosoever has uh, paid the premium, he might have paid the premium or whatever, right? That is not a big deal. Question is, suppose A has paid the premium. That means what? A has right to sell, right? Now question is, when can he sell? That means what? So suppose here they will fix. It's not like they can always sell at rupees 25 per kg. We all agree. It's not like, right? There should be some time. So suppose for 1 year, for next 1 year, they have fixed that he will sell the wheat rupees 25 per kg. Agree? So what the contract in both of them? Please try to understand that A has paid a premium to B and B has agreed to buy, right? B has agreed to buy the wheat 25 rupees per kg for next 1 year, right? And A has right to sell. Right to sell means if A wish, then A will sell. If A does not wish, then A will not sell. I don't think any issue in this, everyone, right? Okay, so now the question is, what is European and American option? Anyone from the audience is knowing it? Okay, it's okay. So what can be the possibilities? First possibility, that anytime till 1 year, right? Till 1 year. Anytime till 1 year, A goes to B and sell the wheat. Because A has right now. So B cannot come that, okay, I'll buy. No, because B does not have. B has taken the premium. So please try to understand. It's not like B come to A and I'll buy your wheat. No, B cannot say, right? B is obliged only. A can come. Yes, A has right. Whatever the day, suppose it is the contract is valid for 1 year. A has woke up any day and he went to B and he said, though, I will sell the wheat. Now, I'll give you 100 kg, you give me 2500 rupees because we have that contract. Agree, everyone? Another scenario is only after 1 year. I mean, today the 1 year is completing. Only after 1 year, A is going to B and sell wheat. Everyone comfortable with these two concepts? So European and American style option, actually it is concept related to time. It is a concept related to time. Agree? So now you tell me that all of us agree that these two cases may arise. These two cases may arise. So anyone from the participants knows which is European, which is American? So if it is any time, right? So this is called American style option, right? Okay, and if only you can exercise the option only at the end, this is called European. Everyone comfortable? And why do we need these two kinds? This is important now. Why do we need? Yes, it is needed because in many situations, just like wheat and bread, going for European is not a good idea because he'll be needing wheat more and more, right? Many times in a year. Agree? And suppose it is a insurance. So there it can be European also. Why? Because okay, you collect the claims, all the claims, and we will sort out all the claims after 1 year or after 1 month, whatever. Are you getting my point? What I'm trying to convey? That why do we need to categorize this? That is important, nah? If there is no need, then why we are categorizing? So what is the need to categorize it? Because in certain cases, uh, we need to exercise the option at any time. But in certain cases, it's okay. We will exercise the option at the end. Okay. So where we can exercise the option at any time, that is American option, right? So basically what I'm trying to convey, that suppose A wants to sell at any time his wheat, that means A and B should be agreeing on a American option contract. And if A wants to sell only at the end of 1 year, then A and B should have a European option. Okay. Now I'm using, so we understood call and put, we understood European American, but I'm using one terminology and I'm not sure whether you are comfortable with it or not. See, we are going to do Black-Scholes PD, but before that, we must understand these small things so that you feel confident in option pricing problem. Okay. So I'm using one more word here, exercising the option.
Sir, here can we have any other example apart from this? Like,
Okay, fine. You take that wheat and bread I took, na? So what do you think? What example can you think of? You tell me, I'll tell you in that context.
sir, I mean, for example, if it is a company, right? And in
Okay.
American style option, like if a person is traveling somewhere, so he can ask his senior for getting reimbursed on the spot. Like if he's buying some goods, so he's taking on the spot, like from the what is it, accounts department, and the accounts department is having that on hold. Then the second option, European option, if the accounts department is having that, then he will claim it later.
Exactly. So I gave that example, na?
That
That
is a
insurance example.
reimbursement, I suppose, no, sir? Why? Because whenever we travel somewhere and whatever expenses we do, then later on we submit that bills to the college or maybe might be this company. So they
Yes.
reimburse that same amount, right? So that is a European option.
Yes.
And
Yes.
American
So
style option means like whenever we are going for some maybe some like since I'm research scholar, sir, so we go mostly go for any viva or something, no, sir. So we buy on the spot and we collect the money from that particular research scholar itself.
uh, yes, you can say, but there is no premium involved, na, in that. See, first one is okay. First one is just like I gave you. Okay, let me try to explain you. If not, then see, if you take the example of health reimbursement, medical reimbursement. Suppose you are an employer, right, somewhere, and you are taking medical reimbursements, and you are working in a company or maybe in some institution, and so we all know that some fixed amount we deposit as a contribution, and based on that contribution, suppose you are a state government employee, so you deposit CGHS contribution. It is there, right? So you deposit some contribution, and if you don't deposit, you will not get claim. Agree? So you deposit some contribution, so that you can consider as a premium. Agree? Now there again there can be two possibilities. What? That your account department has instructed every employee that since it becomes difficult to process it again and again, so you can only come at the end of that financial year to take your reimbursement. So this is European option. And
Yes, yes, sir.
if your account department has not made any such condition, and he said that okay, whenever you are having some bills, you can submit it to us and we will reimburse it. So that is American. And here, why I gave you this example, because here the premium is also involved, right? Because you have paid that premium. Nah? Agree? So you have the right, but please try to understand. If you want to have the American option contract, you have the premium will be different. If you want to have the European option contract, the premium will be different. So just like think here, right? If A wants to sell wheat at any time throughout the year, of course the premium will be more, right? Our premium will be different. But if A wants to exercise
Yes,
only
sir.
at the end, the premium will be different. So we can take. I'll tell you. I'll tell you much more examples. Right? Let me show you one image. Just 1 minute. Okay. So yes. Just yeah. So I'll be just showing you in a minute. But please let me complete this concept, because this is you must be. I mean, you may have confusion in this. What is exercising the option and what is selling the option? Please try to understand. Again, I'm trying to recap. We understood call and put option because it is simply who is having the right. You are having the right to buy, or you are having the right to sell. Okay. European and American, these concepts are related to the time, right? That means whether you want to exercise it at only at the end maturity, or you have the right to exercise it at any time. Now, third concept is I'll be showing you different kind of options, and there I'll give you many more examples. Okay, please wait for maybe 2-3 minutes. So, but can anyone tell what is this exercising and selling the option? So try to understand. Let me give you example. So suppose Sarthak has purchased an option that he will buy. Okay, so Sarthak has purchased option, purchase a call option of a company share, and he said that he will buy, suppose it is a European option only, no issue. And suppose what is the company call option of a company share, that is he will buy that share, that is stock, right, at rupees 100, or anyway, just leave it, make it even more simpler. Call option to buy an asset, right? Let me make it even more simpler, at rupees 10,000, right? So Sarthak has purchased a call option. That means what? They will on one side there is Sarthak, on another side is seller of that asset. And what has happened? Between both of them, Sarthak has paid a premium to seller. Agree? Please be clear. Because Sarthak has call option. That means Sarthak has right to buy. So Sarthak has paid the premium. Agree? Now what happens? And why? Because Sarthak is having that guess that price of this asset might shoot up after 1 year. So let us fix it now, and I'll buy after 1 year. But then after 6 months, maybe it is it is European option for 1 year. Now after 6 months, Sarthak feels that he does not need that asset. What he'll do? He will sell that option to some other person, right? He will sell that option means whatever the option means, what? That contract, right? That contract, whatever the premium of that contract. So he will sell that contract to some other person. Suppose that person is Aditya. Because why? And why Aditya purchased it? Because Aditya wants this asset. Aditya wants this asset. So now Aditya will go to seller of that contract, because and then he can buy. So this is called selling of options. It's not like if Sarthak has the call option, only Sarthak can buy. No, Sarthak can sell this option to Aditya. Aditya can sell this option to any other person, and in the same way, but who is having the contract? What this seller will see that, oh, you are having the contract. Okay, you can buy. Is it clear to everyone? This is called selling of options contract. Then what is exercising the option contract? Anyone? So exercising the option contract means the original two party when they exercise. So now Aditya will go to the, right? Aditya will go to the seller. Aditya will pay. Aditya will pay 10,000, right? And seller will give him the asset. Give the whatever asset, anything, right? This is called exercising. Exercising means for whatever reason this option was written, what it was written, that okay, seller will pay you 10,000 rupees and will buy the asset. This is called exercising, and this is called selling. Everyone is comfortable with this because it is a bit crucial, right? Please try to understand. It is a bit crucial. So I just request everyone that if you are not comfortable, please do let me know. Okay, anyone?
Sir, that exercising part, sir.
Come again, please.
That exercising, sir. Could you explain once again, sir?
Oh, fine. Sure. Yeah. So again, see, let us try to understand it by example. Otherwise, it might be a bit confusing, right? So again, I'm trying to explain that a person who initially bought the option contract, Sarthak bought the option contract. What does it mean? Sarthak bought the option contract. That is, that is, uh, Sarthak has paid some premium to the seller, and Sarthak is having a right. And how it is done? So, okay, Sarthak and seller both have signed on a paper that okay, Sarthak has paid me the premium of 100 rupees, and Sarthak will buy the asset from me in rupees 10,000 after 1 year, because they have signed a European option. Okay, so this contract Sarthak has, because if suppose seller says that, oh, I'll not sell, Sarthak can show that contract. Okay, you have signed here and you have agreed on it. Agree? It is done. Now after 6 months, suppose Sarthak feels now he doesn't need that asset. So what Sarthak can do? Sarthak can sell this option contract, that piece of paper. So what is the price of that paper? 100 rupees, right? Initially 100 rupees. Now it will be what? That is a question. Please try to understand. Initially that piece of paper was what? 100 rupees, na? Because Sarthak has paid 100 rupees to paid the premium of suppose 100 rupees. Agree? So Sarthak has paid the 100 rupees premium. Now how much he will charge to Aditya? That is a question. That is a question mark. Agree? But Sarthak can sell that option contract to Aditya, can take some money, he will give some money, okay, and now the owner of the option contract is Aditya. So this is called selling of contracts, selling of option contracts. Okay, this is called selling of option contracts. Okay, but what is exercising of option contract? Exercising is simply means that at the end, whosoever is the owner, doesn't matter. See, seller is not like, just like you think, nah, that warranty. Suppose I purchase a car, okay, and I purchased warranty of that car, okay. I have paid the premium to the warranty issuer. Now I sold my car to Aditya. So, and I took money for that, right? I'll take the money for car also, I'll take the money according to the my insurance also, everything, warranty also. Now if Aditya will go to the warranty, I mean showroom, can they deny? No, they cannot deny. They only need, oh, you are the owner, you are having the warranty, it's okay, I can give you the warranty. Got it now? So I am selling to Aditya, this is selling of options. Now Aditya is going, suppose car is damaged somehow, and Aditya took that car and go to showroom that, okay, now it is in under warranty. No, seller will not say, no, call Kuldeep, then only I'll give you the warranty. I think it is perfectly clear now, right? Seller is obliged to that paper. Aditya is having that paper. Now Aditya will claim that. I hope now it's clear. Selling and exercising. That exercising is that, yes, good. So exercising is at the end who is claiming the asset. That is exercising the contract, right? That okay, because once you exercise, it's done, over, right? But selling is that I can sell my car to Aditya, Aditya can sell to Jai Kishan, Jai Kishan can sell to Sarthak, doesn't matter. I hope I'm clear till here, right? Okay, so let me show you please try to understand. We are just filling up the uh, gaps before going for numerical methods to, and see, the question is still that same, that what will be the premium? If Sarthak has paid that premium, how did you decide that rupees 100? Who said it will be 100 rupees? So our key question is still unanswered, that how to compute that premium. We discussed that yes, Black Scholes has provided one differential equation uh, to uh, get the premium. But before we go to Black Scholes equation, we will try to understand at least the basic ideas. Let me share one picture that is much more beautiful. Yeah. How many of you can see this figure? Just a minute. Yeah. Right? You can see this figure. I request everyone just take a couple of minutes to try to understand it. And this figure, I'm just trying to tell you that you said, nah, that can you give me other kind of option example? Actually, that's why options are more popular. Why they are more popular? Because they can be designed as per the person's need, right? As per the person's need. So if you see here, let me see. So stock is nothing but just any asset, right? It's not like any stock. Stock means simply any asset, right? Okay. So from the stock we define derivatives, and yesterday we understood that why it is called derivatives, because it is derived from that stock. Okay. And derivatives we discussed yesterday, that forward, future, options, swaps. But our course is mainly focused on this options. Okay, so options can be, if and they can be classified in many ways. It's not only this way. I have just tried to give this picture to you. Maybe I'll share this picture in the group. So options can be of vanilla type, exotic type. What does it mean? Vanilla means relatively simpler one. Exotic, they are tough, right? Why they are tough? Let me tell you. So here, Asian option, barrier option. So they are defined where the premium depend on whole year price. So suppose, okay, let me give you one example. So there is an asset, whatever your asset is, right? So Asian option means Asian option, right? How will you find the premium of Asian option? It will depend on the, so suppose, okay, now let me tell you. By example, maybe you'll get it. So suppose I take warranty of my car. So what it will depend? It will depend on the what is the price of car at that time, isn't it? Price of car at that time. Suppose you buy your warranty of your mobile phone. So it is price of mobile phone at that time. Based on that, the warranty cost will be. We all agree with it. But there are certain situations where the price of premium will depend on its price throughout the year. It's not only original price, its price throughout the year. The option value will be computed using the asset price throughout the year. So there we use Asian option. Please do not be confused if you are not comfortable. I'm just trying to explain you that various kind of options are designed. This is first point from this figure. Second, to compute European option, American option, Asian option value, right? That premium, please try to understand, right? To compute that premium, we have several models. Black-Scholes model, right? Jump diffusion model, stochastic volatility model, multi-asset model, regime switching jump diffusion. So what I'm trying to convey, those who are involved in research, actually this picture is for those only, those who are involved in research. Let me, and I mean, those who are research scholars or faculty members, what is for them in this whole context? Whosoever, if you are a BTech student, you must be having your BTP, right? BTech project. If you are MSc student, you are having project. If you are PhD student, you may explore this dimension. Okay, so what are the research problems arise here? Try to understand, right? So today what we understood, yesterday we saw that, okay, a PD comes which helps us to get the option price. But we could not jump directly to PD because there are certain things which we need to understand first before coming to Black-Scholes PD. Till here it's fine. Now, today we tried to fill the gap. We understood call option, put option. We understood European option, American option. We understood what is the difference in exercising and selling the option. But so after reading this much, the question is again the same. How will you decide that option premium? Right? And for that question, I showed you several models have been developed. These all models are after 1973. Please try to understand. These all the models which I showed to you, they are after 1973. They were developed, and different kind of options are computed from different models. So what is the research problem for you people, right? What is the research problem for you people? A new model can be developed. New model to compute the option price may be developed. Everyone agrees with me? What we have seen now: jump diffusion model, Black-Scholes model, regime switching jump diffusion model, Heston model. So you can explore the literature and then you understand, oh, I can give a new model, right? This is first research problem. Second research problem, what it can be: incremental change in the existing models. Okay, let me tell you why so many models. Because the simple answer is that no model is perfect. That's why so many models. Suppose there is a perfect model, so then why do we need many models? We don't need. Agree, everyone? So we need many models. The reason is simple, that no model is perfect model. All of them are having some pros, some cons. Agreeing, everyone? So what we have now as a researcher, what we can do, either we can propose a better, of course, right? If it is worse, then no need to propose. So we can propose a new model to compute the option price, or what we can do, we can do some incremental change. Suppose we do some change in Black-Scholes model, and we can show that, oh, our model is giving you accurate option price as compared to Black-Scholes. Agree? Right? This is one thing. Or so we can do incremental changes. Third is important, that model is proposed. Model is proposed. Model Model means either partial differential equation or partial integral differential equation or anything is proposed by someone, proposed already, right? PDE, partial differential equation, partial integral differential equation. It does not have closed form solution. So what does it mean? That suppose Athav, what Athav did? Athav proposed a model and Athav derived a new differential equation. Try to understand, right? So this comes from here only. This comes from here only. Athav derived a new model and Athav is very sure that yes, it is going to work. But then it does not have closed form solution, that he cannot solve it using pen and paper. Closed form solution simple, right? Pen and paper. So how many of you are familiar with heat equation? I believe many of you are familiar, those who have done any course in mathematics or partial differential equation. So heat equation, you can simply solve it using pen and paper. No need of any computer or anything, right? But unfortunately, Athav derived a good new model by using mathematics, but Athav could not solve it using pen and paper. Then what? This is third research problem. Please try to understand. Okay. So this is first, this is second, and this is third. So then what do you think? Numerical methods are essential. And then this is again a new domain, completely new domain, isn't it? No closed form solution or no analytical solution, then numerical methods are essential. And this is very much important. And that's what if you see our schedule, I am supposed to discuss this numerical methods, right? I'm supposed to discuss this numerical methods. So when everyone understood this research problems, I believe, right? So what is the idea? If no model is already proposed and a lot of people are working in that, so please try to understand, for this you need a new model. To propose a new model, you need probability, you need statistics, you need functional analysis, right? You need measure theory. All of you have heard these subjects at least. You need optimization, right? So you need these many things to either propose a new model or to change incrementally, I mean to do an incremental change in the existing model. All of you agrees with me, right? So for that, if you are working in any of these domains, probability, statistics, function analysis, measure theory, optimization, then you should think of developing a new model or to do a incremental change in the existing model. But suppose you realize that lot many models are developed, people are working in those dimensions, right? If no closed form solution, if exist, then what will happen? So you for that PD PID, for PD PID. So what happens? Suppose Aditya has developed one PD, partial differential equation, which is different from Black-Scholes PD, right? So and unfortunately he could not solve it using pen and paper. Then solve it numerically. Solve it numerically, right? And what are the popular methods for solving a partial differential equation? Anyone? Anyone heard of, anyone did any course on this partial solving partial differential equation numerically from the participants? So very popular approach is finite difference method, right? Finite difference method, we call it in short FDM, right? Finite element method, right? FEM, we call it finite volume. It's not two, three, it's too many. FVM, radial basis, wavelet methods, etc., etc. So many, right? Galerkian collocation method, Galerkian, so many methods, right? So we, from this whole, what we realized till here that yes, question is that one single question: what? How to compute that option price effectively? How to compute that option price effectively? But to solve that question, right? People have used, and it's not only that the way is using partial differential equation or partial integral differential equation. No, there are other ways also, but this course is mainly focused on the PD approach. You want to get the option price, right? You want to get the option price using by solving a PD. Okay, so I will not be going in the derivation of black holes. That will be done by Professor Obeck. That how will you get option pricing PD? How he will derive, right? That how did you get option pricing black holes PD? That will be done. If you see the schedule, it is already mentioned that he will be discussing uh, that how to derive the black holes PD and black holes formula. Okay. Now, so till here, is it fine? Or any queries from anyone? Right. So now, anyone? Okay. So now, what we understood that, okay, we understood all the basic concepts, European American, call, put, exercising, selling. Why do we need numerical method? That is most important. And now it is time to get option price from Black-Scholes PD. Right, it is the time to get option price from Black-Scholes PD. So now we are coming, of course, once we understand the PD, then only we will go to solve it, right? Otherwise it is not good, right? So first I think we should understand the Black-Scholes PD a bit, okay, and then we will try to understand that how we can solve it using finite difference method. So please try to understand that in our lectures we will be mainly focusing on finite difference method, that how finite difference method can be used to solve this Black-Scholes equation, or not even Black-Scholes equation, even complex partial integral differential equations and system of PDs, etc. Okay, so let me discuss first this Black-Scholes equation, and then maybe I'll come to finite difference method. Okay, so Black-Scholes equation, right? So what do you think? What is special about Black-Scholes equation? I mean, why this equation became so popular? Right. So let me write first. Right. So what Black-Scholes did, they gave this one partial differential equation, del V by del T plus half sigma square S square. We will try to understand each and every term. Don't panic, right? Del S square plus RS del V by del S minus RV equals to 0. Okay, let us try to understand this equation, and then we will try to understand why they got, for this work they got Nobel in 1997. Yesterday we discussed, right, that they got Nobel Prize in economics in 1997 for this seminal work. So what is special about this? And right, so tell me, uh, so V is the value of option. V is what? Value of option. That is value of premium. And those who are comfortable, at least in differential equation, they may get an idea that yes, if you solve this equation with some initial and boundary conditions, we will discuss later, with some initial and boundary conditions, then whatever V you are getting, what? V you will get, and that V will be nothing but value of option. That's great. If we solve this V differential equation, this will be a value of option. What uh, Black-Scholes said that your V will be a function of S and T. What does it mean? What does it mean? That your value of option depends on the S. S is what? Asset. Price of asset. So try to understand that suppose I want to take warranty of my car whose value is 10,000. So here the asset is my car. Here the asset is my car whose value is 10,000. So here S is 10,000. Agree? So price of asset, but that asset will also price will go up and down, right? It is not fixed. In a stock market, do you think the stock value is fixed? No, it's not. It is always changing. Stock price always changes. But yes, we agree that suppose I want to buy a stock and whose price is changing continuously, agree? So S denotes the price of that asset or stock. V denotes the value of option. So we are formally agreeing that yes, our value of option will depend on this price of stock. For sure, right? Yesterday also I gave you the example. If you are buying the insurance for 10,000 rupee phone, and if you are buying the insurance for 50,000 rupees phone, so the option premium will depend on this 10,000 or 50,000. Agree? Another idea is that V is depending on T also. Why? If you want to take a warranty of 1 year and if you want to take a warranty of 5 years, don't you think the premium will be different? Agree? They will be different. We all agree with this. So Black-Scholes said that V will be depending on S and T. What is R here? Risk-free interest rate. What does it mean? So our investment or every economic activity will depend on that what is the risk-free interest rate currently. Let me explain you in a different way. Let's suppose I have 1 lakh rupees, right? So, and I want to invest in a stock. So I always have this in my mind that, okay, today the interest rate is 5%. If I will invest in bank, I'll get 1,05,000. That means what? Risk free. 1,05,000 is risk free. So if I'm getting more than this, then only it is beneficial to invest in stock market. If I'm not getting more than this, then why should I invest in stock market? Okay, so that risk, and what is the risk free interest rate? That 5%. That 5% is the risk free interest rate. That okay, uh, if you invest in bank, you'll get R% of return. So R is the risk-free interest. So in this above PD, and T is time, of course. T is time. So time will be what? From 0 to the maturity time. Time will be what? Today I get into contact with any, suppose Sarthak is the seller of option, I am the buyer of option. I and Sarthak wrote a contract that okay, I will buy this asset from Sarthak after 1 year. Okay, so from 0 to 1 year, this is small t. Right. So, and last is what? The sigma. That is called volatility. These 5 variables are there in this equation. Any other variable? right? These five variables are there in this equation. Agree? So P is the value of option, S price of asset or price of stock we can say. So now let me explain here, then maybe it will be more interesting for you. So suppose there is a stock, okay? This is a share of TCS, share of TCS, and its value is today 100 rupees. Now we all know that it will not be fixed. It will move up and down. We all know, and it will be some value after 1 year. This is 1 year. Everyone agrees with me, right? Now Aditya wants to buy this share after 1 year. Okay. So Aditya wants to buy the share at, right. So Aditya purchased a call option from TCS and Aditya fixed. Aditya bought a call option and Aditya fixed that, okay, I'll buy this share at rupees 105 after 1 year. So everything is clear here that Aditya has fixed one price that, okay, at this price I will buy this share after 1 year. TCS says what? You give me some premium. So Aditya paid some premium to TCS because Aditya wants to have that right. Agree? So here T is what? 0 to 1 year. Agree? R is what? R is fixed by bank. Aditya went to bank. Bank said that R is now 5%. So Aditya knows that bank interest rate also. S is what? 100 rupees. And question is what? How much Aditya should pay to bank? TCS, sorry. How much Aditya should pay to TCS? Is this figure crystal clear to everyone? I request some of you please respond because then it will be more interesting, right? Otherwise, yeah. So this figure is clear, right? What it is saying, how much Aditya should pay to TCS. Okay. Now, the idea is what Black-Scholes said that, okay, you solve this PD and you'll get V because the rest of the things we know. Please try to understand. R we know from RBI. S we know what is the value of asset, right? T we know how long you want to be in the contract, 1 year. Agree. Sigma is crucial. Sigma is crucial. Volatility in this asset price. Sigma is literally crucial. Yesterday also someone asked to Professor Obek, and again I'm telling you, sigma is how volatile your stock is. That means how frequently the price of that stock is changing. Okay, how frequently the price of that stock is changing, that is sigma. Everyone? Everyone? Right? So the idea is simple that, but Black-Scholes assumes that this sigma is constant. That we will discuss in detail. What are the problems with Black-Scholes model, etc., etc. Right? So Black-Scholes assumes that this volatility is constant. Please try to understand. So what Black-Scholes assumed? They assumed that this volatility is constant. Do you think this volatility is always constant? Constant means a stock price is moving, I mean, in a very uniform way. And never, right? We all know it is not constant. Agree. So this was, we will discuss some limitations, some advantage and some disadvantage of Black-Scholes model. So first let us discuss the advantages, right? So Black-Scholes assumed that, okay, we know sigma, we know T, we know R, we know S, and one more that one more term they did. They used the one more quantity that is called K. That is not in PD, but that is used, right? So K is called strike price. Can you guess what is the strike price here? Can anyone guess what is the strike price here? Right. That is at which price we are exercise price. Yes. But thank you. So strike price are sometimes called exercise. That means at which price we agreed to buy our. Today's price is 100, so that is S. Today's price is 100, that is S. But at which price we agreed? So what is the strike price? Let me write. At the price we agreed to buy or sell. I hope everyone is comfortable, right? Everyone is comfortable. So now what we realized, we understood all the terminology of Black-Scholes equation, right? Let us quickly discuss. First, let us discuss its solution. Okay, now let us first discuss some some advantage and disadvantage quickly. What is the advantage? That they solved it using pen and paper. They do not need any numerical method. That's a great thing. Why? Because if they can solve it using pen and paper, they provided a formula. Okay, so they provided a formula and they said that, okay, using this formula, you can find the price of call option. That's great. So let me write it. Then only you will realize that, see, they got the Nobel Prize. It must be something very unique, right? So what is the idea? They gave one simple formula. What they said? That what you do? You solve this equation, solve this PD analytically. It's not numerical or something, because if there is anything numerical, there must be error. Numerical error will be there. But no, they said I solved it analytically and I got this price of call option equals to, they said that this V is what? Price of call option. Please be clear, right? Value of option, right? So price of call option is equal to N of D1, right? S minus K e to the power E minus R T minus T N of D2. Seems complicated, but it is not. Please don't worry. Okay. So let me write it in this way so that so S of N of D1. Okay. What we realized that they gave this, and what, so now what is the advantage of this formula? I'll come little later. What are these terms, right? But what is the advantage of this formula? Can anyone guess? If we have this is called Black-Scholes formula. This is called Black-Scholes formula. And Professor Overbeck will tell you that if you solve this PD, how will you get this Black-Scholes formula? He'll tell, right? But can anyone guess what are the advantages? If we have this kind of formula, what is the advantage? Basic advantage is it is person independent. Why? Because if we know S, if we know K, if we know R, if we know T, whatever price Siddhant will calculate, the same price Pooja will calculate, the same price Athar will calculate. What I'm trying to convey, that it is not depending on your knowledge. So you know so many things about financial market. Suppose Siddhant is knowing so many things about financial market, Pooja is not knowing. It's okay, no issue, because it is a formula. You have to just put all the values and you can compute the price of column. Before Black-Scholes, whatever the methods were derived, they were involving this one factor, that okay, how much you know about the financial market, or how do you understand the financial market. But this formula is independent, and it is not like Okay, I don't know anything about market. It's okay. You give me S, you give me K, you give me R, you give me T. I'll tell you option price, and we'll do this in MATLAB. That's great. So this is first thing. So how many things? The great things about Black-Scholes PD. Let us quickly. Okay, let me tell you what is D1, D2 first of all. Right. So please do not panic. You know S, no issue. You know K, you know exponential, you know R, you know T. T is 1 year. Capital T is means how much time you are fixing for that. Right. What is D1, D2? That is important. So what is D1, D2? D1 is nothing but 1 over sigma root t minus t log of s by k, right, plus r plus sigma square by 2 t minus t. Okay. Just wait, let me check once. I think yeah, fine. Okay, and what is d2? That is d2 is nothing but d1 minus sigma root t minus t. That's fine. See, it is complicated, but doesn't matter, right? Why? Because you don't need to compute it using pen and paper. You can simply take the uh, help of computer. You can simply write a code. It can give you the value of the value. And all the parameters you know. You know S, you know K, you know R, you know sigma, you know T, everything you know. So that is the main reason why they got the Nobel Prize. What it is that if you take any asset, right, you know S, you know K, and so suppose Aditya wants to buy this asset of rupees 100 in rupees 105. So K is 105, S is 100. Sigma Aditya got for that stock price. How will you get sigma? Sigma you'll get from the past data, right? But here they assume that sigma is constant. It's fine. We can assume for the time being, okay. We agree with Black-Scholes that, okay, although this is a limitation, but it's okay, right? Not an issue. So they said that if sigma is constant, then we can simply figure out the value of option using this form. So what we have understood till here, we have understood that Black-Scholes gave one partial. So okay, let me summarize so that you can I mean understand pictorially. So first, Black-Scholes derived a partial differential equation for European call option. Good enough? Then it's not. Suppose they have only derived and they could not solve. Do you think it is much useful? No. Then again, it is not much useful because many people might have derived the model. I told you. I told you here. Only developing the model is not sufficient. Either you solve it using pen and paper, or you solve it using numerical methods. Because you derived the model and no one is able to find out the option price from them. What is the use? No use. Agree? So then first thing is that they derived this PD, then solved. Right? They found a closed form solution. This is closed form solution. Closed form solution simply means that you can simply compute it using pen and paper. And okay, what is n of this? Can anyone tell? Oh, I just missed. N of something. This is CDF of normal distribution. So probability is involved here. Please try to understand. Probability is involved. So you have to see the table, right? And then you can figure out this value of n, this value. How will you figure out this value? From the table. But it's okay. Whatever it is, we know everything. There is no problem. So the best part about Black-Scholes model was they derived a partial differential equation for European call option. They solved it, and despite several assumptions, is still giving very accurate results. It's not perfect, I'm saying, right? But it is giving still, it is still a benchmark. What does it mean? Benchmark? That people, uh, suppose you have some asset, you want to buy or sell, so you want to see how to find perfectly option price. That is difficult. It's okay, I agree. But how will you get the at least a benchmark? At least a benchmark. That okay, option price would be 50 rupees, or it may be a bit more than 50, a bit less than 50, but at least you get at least a benchmark, right? So Black-Scholes model is still a benchmark for option price. Now let us discuss a few drawbacks. So what is the drawback? Can you think of what's the drawback? So advantages, right? And limitations you can think of. What are the limitations? Can you tell? The very first limitation is the assumed volatility is constant, which is not. Constant volatility. Very good, Siddhant. Thank you. Next, what else? What else? It was only for European. What about American? What will do? Isn't it? Isn't it? So suppose I want to have an American option. We have discussed. That's why actually, please try to understand why I told you call option, put option, why I told you European option, American option. This is important. Otherwise, you won't be able to get it right. So, but still we see there are lot many advantages over disadvantages. Still, you believe me that people are using this Black-Scholes model as a fundamental benchmark for this option pricing problems. Yes, good. So, Aditya, okay, just telling you, just let me tell you. Immediately, I'll tell you, right? No need to worry. So, otherwise, I may forget. So, someone is asking about some reference. It is fantastic book, right? So, I'll tell you maybe for as of now, I'll tell you about a book for option pricing and numerical methods. Later on, I'll tell you about the machine learning related book also. Okay. So, Adit, the reference book you can take it here only simply, right? The book titled as computational, because you might be interested in computational methods. It also involves theory. It doesn't mean that it does not have theory, right? Computational methods for option pricing, right? Computational methods. Okay, you haven't studied PDs yet. Okay, great. No issue, Aditya. If you see this book, they have wonderfully uh, explained the model first, and then they have wonderfully explained the PDs or PIDs, whatever it is, and then they have explained how to solve these equations. And the author, this is title, okay? So let me write it in the way. This is title. The authors are good, great. Then you'll be Y. Asdo and O. Pirno. Oliver Pirino. These are two authors, and publisher is Siam. Publisher is Siam. Okay, so you can all of those who are interested in working in this domain, I think this is the fantastic book, and it provides codes also. The best part is they provide algorithm also, although that algorithms are in C, I think, right? C or C++, but that is fantastic book, that how you should proceed for option pricing problems. And there are many other books. Maybe if I'll see if I can, I'll suggest you in the group also, right? So if you feel that, but I feel that if you are studying it from the aspect of data science or from the aspect of scientific computing, I think this is the best book you can, I mean, you can look into it. Okay, so we understood that it is limited to European option only, right? And the volatility was assumed to be constant. Okay, now, but there are still various several advantages. So what to do, right? The question is what to do now. We have advantages, but still this model is not perfect. Agree? This model is not perfect. So fine, for black souls we could find the solution on pen and paper, but for other models, what about other models? Let me show you that image again. Just 1 minute, okay? Yeah. Because once you understand the feeling of that, right, then only you will be able to appreciate. Yeah, so what about these models? How will you solve jump diffusion model? Because for jump diffusion model you don't have analytic solution for so what will you do? Did you get the essence? The essence is that fine, for black Scholes model we have analytical solution, but black Scholes model is not enough for us. Maxwell's model is not enough for us. That means, so the conclusion is to need to develop or extend. Either you develop or you extend black souls. We all agree, right? And there you get jump diffusion models, right? Jump diffusion. What it is will not go as of now. We may go later. Jump diffusion models. Those who are interested, they can explore, or stochastic volatility models. Right? But and they do not have any closed form solution. So what to do? So now the essence is we must understand properly the numerical methods to solve these models. Okay. So we have come again, and option pricing part is complete now. So what we are going to do, we have completely understood that we need what kind of, I mean, what do you need in a numerical method? I'll discuss in detail that what a numerical method, what kind of numerical method we need. It should be accurate, efficient, right? We will discuss in detail. But we have reached to the conclusion that we need a numerical method to solve these PDs and PIDs. What we are going to do in the next sessions, let me tell you a bit. And as a numerical method, we are choosing finite difference. Many reasons for finite difference, we will discuss those also, right? Finite difference method. Once we will understand finite difference method, we will first apply it to simple heat equation, right? Then we will apply it to Black-Scholes equation, right? Why we are applying to Black-Scholes equation? For Black-Scholes equation, we already have closed form solution. Why we are applying to Black-Scholes equation? That we will discuss, right? And if suppose, let me tell you here only, suppose your method, whatever method you developed, that is working for Black-Scholes equation perfectly. So then that method you can apply for jump diffusion models. That means what? Oh, now I have, so what we did, this figure you see that, oh, great. Now I have developed, third one, I have developed a method. You give me any new model, I'll be able to solve it using my method. So what is my purpose now? I will develop a good method, good numerical method. If someone proposes a new model, I will quickly solve it using numerical method. Because we know that closed form solution will not exist in most of the cases. So we need good numerical methods to solve those models. Right. So our next few, at least 2-3 lectures will be based on this finite difference method only. I don't know whether you are familiar. Anyone familiar with finite difference method? And in one lecture, we will also discuss application of machine learning also. So one lecture, we will discuss the application of machine learning, but in other, I think we have 3 more lectures, right? Lecture and tutorial, basically, one today and one tomorrow and one day after tomorrow. Okay, see, in all those 3 lectures, we are going to discuss the application of finite difference method for heat equation, Black-Scholes equation, jump diffusion model, etc. We'll try to understand the properties of finite difference method. When you say that method is accurate, method is not accurate. So this we are going to do from the next lectures. Any queries if you have, you can ask, otherwise we can wind up here. And please, my only request is that please do attend the next lecture also, which is by Professor Obek, which will start at 11:30. uh, right? So he'll be teaching theoretical aspects of option pricing. Now you will feel more comfortable because now you have understood. I think those who are not getting the basic terminology, you might not be from the option pricing field. So now it will be more comfortable for you. So if you don't have any questions, so we can wind up this session. Thank you. I must thank you all for joining this session. But again, I request everyone that please join the